Okay, where am I? Render. Render. So let's think. This bit needs to come out, and basically I think it needs to go into something which will be called something like CXCY, PCX, PCY. I think I'm going to use those. This here will be function render OGL void. Now I don't think actually anything is going to be passed into this because the things that well, I suppose one thing doesn't need to be passed in, and it is, well, it's the number of recursions, yeah, the recursions and the which is a weird thing. Yeah, and it is local to here, and it has to be, because it's going to be the matrix that is passed. So it does need to receive a number of recursions and the matrix. Number of recursions and the passed matrix. G matrix equals null. If not PM, return. And it doesn't return this, it returns a pix map. Return null. And this here goes inside it. Am I brave enough? I am. Makes all this, makes this, then says return pix. Now I'm pretty certain all of the other things here, these little bits can be local, that's fine. Draw curve, no, that doesn't use that, it uses num recursions. And it uses PM. But what I call here, and I'll just quickly write this down, render OGL, and here I say local pix map equals render OGL project recursions and its unit matrix, which is a silly name, but that should be alright now, mate. What? Okay. No, but that's not really what I say. First off, I say local pix map equals null. Then I say select project, what was it, draw mode, case. I did this a second ago and I can't even remember. Right, draw type. Don't give me this. It's right there. I am going to do it this way. It seems redundant, and it is a bit. I could sort of speed this up, but draw type solid, draw type alpha, draw type addition. Pix equals render OpenGL. Case draw type gradient. Do something different. And here it should not be necessary to say that. It should never come here. So here I'm going to say pix equals render gradient. And it will also receive project recursions and unit matrix, and that is that. So now what I have set up are my set of segment matrices, my unit matrix to be passed in and multiplied in as each recursion occurs, and I have my unit set. Let me make sure I have my unit set. Unit set should be global. There it is. Set is in unit. Set is unit form. Don't know what that means. Set, it should be the set in unit form. It's not a very good name. That I know it's not a unit, but it's as if it's a unit. So down here I will have render gradient. I'm going to pack this up a bit. No, that's all. I'm going to pack it up, I think. This calls, yeah. So in here I'm going to have function render gradient. Returns a pix map, receives num recursions and a passed matrix. If not PM, return null. And local pix map equals new pix map project out width, comma project out scale, out height, return pix. Okay. So in here I do a big bit of stuff. Well, what do I need to do? I need to make my data buffer, and I need to draw the curve into it, and I need to use the data buffer to populate the pix map. Populate's a silly word there. To draw the pix map. Now, the data buffer, no idea. Local data buffer equals new data buffer length and byte order. So I just need a length, and And I see that that thing at the bottom there highlighting project output width and project output height, almost as if it's inviting me to multiply the output width by the output height to get an integer. Now am I basically to assume, and I think I probably am, that data buffers, I did notice one thing by the way, I have to use this finish with the data buffer, you should call it inherited discard method, so I must remember that. Let's have a little look at this demonstration. std memory, function main. Buffer is new data buffer 10, 0 until 10, poke byte I, I times 2, print buffer peak byte I. Now, this is maybe me being daft, but is that length in bytes? Oh yeah, length bytes long allocated for me. Okay, right. Memory will be released when I call discard. Okay. And so if I say poke unsigned int, writes a 32-bit unsigned int to the data buffer, and when it says the offset to write, is that in bytes? I'm going to assume it is in bytes, because the data buffer size is defined in bytes. Okay, so I'm just going to spell more of this out. Local buff size int equals project output width times project output height times 4 bytes per pixel. It does seem like overkill, you know, I'm assigning enough space that the line could cross itself 4 billion times. I'm not going to ever draw 4 billion. Like, I did a render once and it took a good long while and it drew a quarter of a billion lines. Even if all of those only crossed the 1 pixel, it would only be a quarter of a billion crosses. It only needs to count to a quarter of a billion. Is there any benefit to me? Or should I just say, well, maybe one day, but then maybe I should say, maybe I need longs. Maybe I should be able to allow it to count to, you know, whatever it is. But I'm going to go for unsigned ints. So, buff size. And I don't think I need anything else. I'm the person reading to and writing from this. This made to sound simple. Buff size integer equals project output width out by time 4. Right. I suppose that I should do something like this. Local data buffer equals, you know, it doesn't equal anything, it just equals null. It's going to be instantiated in here, but I will use the word databuff because, or dataB, because I will use that inside the recursive function which draws to the data buffer. This I think I will make draw curve OGL. This is wrong, isn't it? Oh no, it's not. What is the problem with that? No, it's not a local, it's a global. Okay. Look at that. I already realized my names were bad and put one in there. Okay. Function. Draw curve. Gradient. Void. I see, I suppose, yeah, I mean, I am kind of being consistent here because inside draw curve OGL, it's using the out canvas as sort of the destination for its deliberations. An out canvas is a global reference to a canvas that's instantiated as the curve, for the duration of the render. This will refer to data B, which is a global reference to a destination for its sums, which will exist, the actual buffer itself will only exist for the duration of the render. So I feel okay about it, in a sense. And what it will receive is remaining recursions. I'll try and be more sensible. Rex int comma PM G matrix. Again, remaining recursions and past matrix. Okay. And here I will say draw curve gradient, number of recursions, and past matrix. This bit I'll come to in a sec. Got to draw the actual curve into the data buffer first. It's going to be pretty similar to this, so I'm going to copy and paste it out. Because a lot of it will be the same, I'm just going to replicate it again to minimize what? To minimize function calls in this, which will be called many thousands of times. Look at that, mouse wheel getting worse. Right. So here I use CX for corner X and PCX for, or CXCY and PCX for corner X and previous corner position and previous corner position. So here I say, if I happen to have reached the last recursion, I actually start drawing lines. This is all kind of the same. Do I do a little bit of setup? No, I don't. I basically say, start at the first corner, or start at the first segment, set PCX to be the beginning and CX to be the end. Draw it, set PCX to be the same as CX, then move on to the next corner, advancing this S index. Don't know why it's don't know what those segment index, and it's referring to, no, it doesn't. It just it uses the past matrix to transform the set of lines and draw them. Here it should not do that. It should poke to DataBuffer. Well, it should do two things. It should peek and poke to DataBuffer. It has to peek to read what's there, then poke to increase the value by 1. I see a little thing I have to fix. This needs to become a draw curve OGL, and this needs to become draw curve gradient. otherwise all this is the same. This I need to replace with whatever it is that I do here. I should make this a function call. Well, ideally, you know, if it wasn't for the fact I am trying to do no function calls in here, I will just say, how do I make a simple Breschinem line, or whatever it is? I realise, of course, I'm going to have to do my own clipping. Suddenly I realise that. What is that going to mean, to do my own clipping? In one case, in one sense, I shouldn't worry too much about this. OpenGL must be performing a load of clipping for me, or someone must be somewhere, when I draw the ordinary OpenGL lines using that. So I shouldn't fuss myself too much. There are some things I could probably do though. So yeah, let me have a little think about this, because it might save me huge amounts of time. But honestly, will it really save me that much time? There are so many instances where you just can't tell where a line is going to go. Like I could do a rex hit for every line, which actually is, you know, it's sort of the simplest thing to do. An alternative is that I figure out the rectangle occupied, the smallest rectangle occupied by the set when arranged as a unit. And then, well, then what? I can only actually use that in the final recursion. Like, I can't use the rectangle which encloses an unrecursed set to infer the area covered by a set one step further recursed. If I see what I mean, I'm describing it to myself. I'm pretty sure I can, because I don't really know where the points will. Well, you know, maybe I can say actually. It's just I don't know the sums. Certainly, I can imagine making a rectangle for one set, but to infer the next rectangle based on that, without just drawing out the set, a recursion further progressed, and understanding the positions of all the points. So, I could make those individual rectangles for the segments for the set arranged around the unit. But it would only be at the time I came down here and got to rex equals 0 that I could use that rectangle to compare against the output width and height. But, having said that, that will be many thousands, possibly, yeah, many thousands of lines I avoid drawing. Still have to do a lot of rectangle checks. And even once I've completed the rectangle check, I still have to do like axis align bounding block checks on the lines that I'm going to plot into the data buffer. I'm just talking and talking here as I think this through. What's your problem with this? G matrix not found. Really? G matrix. It's a thing that is not found. I'm sorry, I'm totally... like there, G matrix is found. Here, G matrix is not found. Is that like a joke? I think that like what's possible is I'm missing, you know, some bit of structure, an end somewhere up here, And that's just making the whole thing upset, because that sort of stuff does happen. I know matrix exists, so I'm going to run this. No, G matrix genuinely not found. Draw curve gradient. Draw curve gradient. Can't find the over... If I have to write GUI space G matrix in there when I didn't have to here, I'm going to feel quite confused. Okay, well... Am I spelling it wrong? I am. I don't believe it. My brain, I have to sort it out. Okay, fine. G martix. Okay, well that's that problem solved. What? PM, right, okay. Well, fine, I'll make it easy on myself. Okay. So I think I will do a rect hit lines to display, and then I will just I'll just, oh man, it's difficult because really. So then once I've done a rect hit, my next option is basically to check every pixel. Like one thing I can do is check every pixel. That's a simple thing, but that obviously I don't want to do. If I find that a rect hit is successful, and I am going to step along the line, well, if I could figure out if the line, do something better than a rect hit, basically, and figure out if the line did cross the screen, which I could do by figuring out if it intersected with the line segments that define the edges of the display. Probably some other ways as well. Then I could probably decide the actual point that it enters the screen, and the actual point that it exits the screen. Okay, yeah, actually no, as I think through it, let's see what sort of setup might happen. Because I can imagine a few different sort of scenarios. If the display is here, there's a scenario where a line is here, a segment's there, and that, oops, excuse my terrible lines, that rectangle absolutely misses, so that is instantly discarded. There's a situation where the start is here and the end is there, and that rectangle obviously does overlap, so that will be processed. S and E. There's a type where it starts off the screen and ends on the screen, and again that rectangle obviously overlaps and will be processed. Then there's another where the start and end are both on screen. And I didn't draw that very good for a rectangle, but obviously that will also be processed. So, of the and there is also a kind where the start and end are both off screen, and it will be processed, but no pixel will be drawn. And there's a kind where the start and end are both off screen, but it will be processed and part of it will be drawn. So, different arrangements. A rect hit can discard obviously irrelevant ones. Maybe I'll just even be quite clever. But also a rect hit can allow irrelevant ones, like in this case. It can allow ones which are obviously true and easy to draw. These ones are, well, don't know if I'd say easy to draw. All the ones that cross the edge, my instinct is, once they've passed a rect hit test, is to do the trig, to figure out what is that point, what is that point, that point, that point. Because I think of the line algorithm that I'm going to use, and like I say, I can't remember. Bresenham? I don't know. But basically you decide your start and your end point of your line, and you decide whether the distances, the difference between the start and the end point is larger in the x or the y dimension. And you step through the line in the larger dimension, and you decide in pixel-sized steps in the larger dimension, and you move through the smaller dimension in a fraction. Like, let's say I wanted to draw a line from here. You see, it does work at certain, I say works at sub-pixel levels, but it won't draw like nice lines, but you can move anyway. Let's say I want to draw a line from start to end. This is, and I'll do top down, like 1, 2, 3, 4, 5, 6, 7, 1, 0, 1. Doesn't make any difference. 1, 2, 3, 4, 5, 6, 7. 3,7. Start is 3,7. The end is 1, 2, 3, 4, 5, 6,2. I should have written it this way up, I think, because if I subtract the start from the end, 6 minus 3 is 3, 2 minus 7 is minus 5. I get the move that I've got to make to go from start to the end. The larger of those two values is, well, the greater magnitude is minus 5. So I'm going to step through, I'm going to step through the pixels. I actually think I need to do minus 5 plus an extra pixel, because I want, this is where it gets kind of not interesting, but it gets to be a thing. So the start position is 3,7. I'm going to say draw a pixel in the start position, and then I'm going to go through a loop where I reduce that larger component difference by 1 5 times, so that I'm counting through this, the number of pixels there is between the start and the end vertically. I'm going to go through each one, and I'm going to take the horizontal difference and divide it by the vertical distance. Because I've decided the vertical distance is a higher, the smaller needs to be divided by 3 divided by minus 5 equals, actually I think I just need the magnitude of that, but anyway, I want like a 3 divided by 5 equals 0.6. So I'm going to start at 3 and do 5 steps. So let's just do 5 steps, starting at 3.7. Then, now here's a good question. Now, in one step, I add that 0.6 to the 3, so I get 3.6, comma 6, because this is just reducing by 1 each step. Now's the question. To determine which actual pixel it lies in, should I round it, or should I just should I float it or round it? Round it to the nearest number, or just take the integer part of it? Let's say I just take the integer part of it. That's 3.6, that's there. Then in the next round, I say plus 3 equals that, plus 0.6 equals that. I've got 4.2, 5. And again, just rounding down, 4.2, 5 is there. Then the next round, it'd be 4.8, 4. Again, rounding down. I'm just taking the integer, yeah. Then the next round, we've got 5.4, 3, which is there. And then the next round we got 6, 2, which is there. Now I actually did 6 rounds because I did. Now that looks bloody dodgy as a line to me. The next dot would be there at 6.6 if it was just continuing at this tangent, tangent at 6.6. Then it'd be at 7.2. Then it'd be 7.8. I have a feeling that this is like an actual line, because then it would be at 6. Then it'd be 8.4, and then immediately it'd be up to 9 again. Yeah, and then I'd get 9 point. So yeah, it's got step, 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 step. That sounds annoying, but basically, yeah, that is giving you a line. I could try it either way, floating and rounding. The point is that if I can find those points of intersection for these lines, then I don't bother clipping every single flippin' pixel. I don't have to say to every pixel, are you on the screen yet? Are you on the screen yet? Are you on the screen yet? As I start to work my way. Or if I'm starting on the screen, working my way off, I don't have to say, am I on the screen yet? Am I off the screen? I decide that point at the beginning and work towards it. Or if it's in this direction, I say, well, the end is on the screen. The start has to move from the start to the point at which this segment intersects the edge of the screen. So, 38 minutes of chatting about this structure and this line occlusion thing. But basically this is the plan. First off, a rects hit to see what I can disregard altogether, because there may be many, many thousands of entire sets of lines I don't have to, well, entire lines I don't have to think about. I'm not going that extra thing of eliminating a set of lines at once. Rects hit first to build us to, see if an individual line. Hang on a sec. Yeah, no, if rects hit doesn't hit, it absolutely can't. If rects hit does, it may do. Then I just do some jiggery-pokery. I say if both points are off the screen, or do I actually just look for, if I've found that there is a rectangle overlap, I just look for intersections between the edges of the screen and the points and the segment. I say look for the intersections, see if they lie within this segment and this segment. See that they lie between the ends in both segments. It'd be sure a heck of a lot easier. Man, actually, yeah, these ones where it's got 2 points of intersection on the side of the screen, because there are lots of times the line just goes straight across the display, and those are important. They will help brighten individual pixels. I'll have to figure out a quick way of doing this, or I'll have to give some thought about to how I do it. For the time being, that is 38 minutes of 40 minutes of structure and thinking, and it's going to have to do for now. Next time, I'll start thinking about finding intersections between segments and the display sides.